Okay, we're back in part two of the trivia game board assembly and test. In our last video, we realized that we had an RJ11 connector on the end of the moderator button assembly. So we need to replace this RJ11 connector with an RJ22, which is much smaller. You see it here, much smaller, so it'll fit into the connectors on the daughter board or hat that will fit on the Raspberry Pi. So let's clip that off and get started. We're going to clip it off and we're going to use a razor blade knife to score the outer insulation about a ½ inch back. We're going to be very careful with that to not put too much pressure on the outer insulation. So when you're using a razor blade knife like this, be very careful. Just ease through it. Watch your pressure so that you don't go too far and connect into the inner conductor insulation. When you do this, just kind of bend the cable back and you will see it split open, and just kind of very gently work through it until you see the inner conductors, working your way around very carefully until you free most of the outer insulation. It doesn't have to be completely free. The rest will just pull apart. Take your snips and pull it right apart. There you go. So what we need to do now is measure the length of the inner conductors so that we get enough outer insulation into the connector so that it will crimp and provide strain relief. So take your RJ22 plug or connector, just take a general look, position it to the side, and you can see the position at which the outer insulation will stop inside the connector. And then look at how much extra inner conductor exists and then trim it back approximately based upon your vision. We're going to position this with black, red, yellow, green, where black is to the left facing the gold slide connectors on the plug itself. You can see the four connectors there on the end. Just work it in, make sure it's pushed in completely, and then take your crimping tool and we will crimp it on there securely. Now it looks like I have the wrong crimping tool here. I pulled out the wrong one. So I'll grab the correct crimping tool for an RJ22 or a 4P4C type connector. Now you may have to invest in this if you want to build your own connectors or cables with your own connectors. But if you look on MPS Electrolab site, when you buy the board, there is an accessory kit and we'll provide 15-foot cables with this RJ22 connector already attached. So crimp it on nice and firmly. And now we're ready to attach it to the Raspberry Pi. Here I'm just showing you the prongs that depress the plugs on the plug into the insulation to make sure it's secure. So everything is connected up. We have the four player buttons connected up. We now have the moderator button assembly connected up now that we have the correct connector or plug on the end of the cable. We have taken a USB mini and spliced it into a cable to our 5-volt supply on our workbench to provide 5-volt supply to the Raspberry Pi. Now normally you'll just have a power brick that you would buy very economically to plug into the Raspberry Pi. In fact, when you buy it, you have options to buy these power bricks. In fact, some of the kits come with them. This is our HDMI connector to our TV. You have to have a TV for this video game. It really is part of the whole game experience. So we connect that up. Once again, the four player buttons are ready to go. Red button, blue button connected up, our yellow and our green button connected up, our moderator button assembly ready to go. The only thing that remains is connecting up an accessory. So we have a rotating beacon light here that just adds some splash and pizzazz to the whole game experience. So we're going to use the relay option on the terminal block to connect up an accessory. So let's get our schematic in view here, and I'll describe what we're going to do. We're going to connect a 12-volt supply, so we'll get a power brick. I'm using just my 12-volt supply on my workbench. We're going to supply that into the terminal block. It'll feed to one side of the relay, and when that relay closes, it'll connect out to this siren or buzzer that I show here to activate, in this case, that rotating beacon light. Okay, here's the 12-volt lead from the 12-volt power supply. So I've marked the neutral or the negative line, and we're going to connect that up according to the diagram to pin 6. And we'll go through this in more detail on the schematic diagram a little bit later when we go into we produce our video on the design of the Raspberry Pi hat for the trivia game. And so this is just a simple matter of connecting this up. Now there's a bit of a design hiccup here. I positioned this terminal block so close to the cases of the USB connectors and the RJ45 LAN connector that I had to put a piece of black electrical tape there just to make sure any frayed conductors don't accidentally contact the shielding of those of that RJ45 LAN or USB connector housing. You know, in a future revs, I plan to reposition this terminal block or use what's called a 45-degree offset terminal block so that we don't really have that problem. But in this case, just take a piece of black electrical tape. You know, Scotch tape is the best. Usually I use Model 33, which is really pliable and flexible. Just lay it over those areas, and then as you work these wires into position, if you happen to have, you know, any conductors that may be close to that that shielding, you will not end up with a short, basically. So completing the connections here for the rotating beacon, we're almost ready to get started. So here you can see me positioning the wires, and you see the black electrical tape that I just kind of put over the shielded USB connectors, etc. So here we're going through and checking our connections. So pin 2 is going to be neutral from 12 volts. Then we're going to end up having pin 6 from is positive from the 12 volts. We're then going to have pin, I believe it's pin 4 and 5 to the rotating beacon itself. That allows the power to the rotating beacon to be engaged when the relay closes. If you buy the circuit board from the MPS Electrolab site with the accessories, you get full schematics and a detailed description of how to make these various connections. So don't worry about it too much right now. So here's the rotating beacon. We're all connected up here. Notice the red jumper there. I'm making a note here. I forgot to, there's a particular jumper you have to do to tie the 12 volts back for the internal circuit to engage the LEDs on the buttons, because these are 12 volt LEDs. We have our TV ready to go, our buttons. We're going to power up the TV, and we're going to just step right through the demonstration. So once this boots, we install Raspbian on the Raspberry Pi, and you need to purchase your Raspberry Pi, really do some research, learn about the operating systems, have a little bit of, you know, this takes some knowledge about Raspberry Pi. So once Raspberry Pi boots, we get the wireless network up. So what we're going to do is once this boots up is we're going to start the software, which will execute the game. Here it is going. So we start self-tests at the beginning. We do label tests, and this is always kind of to check your deployment. We're here alarm, and there you go, the beacon. We're kind of doing some tests on the beacon, so that's working. That worked great. Now we're going to do button tests. We're going to flash the button indicators, make sure all the button indicators are working. So now it's an interactive. We go through the buttons to kind of remind you of how your configuration is set up. So this identifies each player that you've associated with the buttons. Later on in another video, we're going to talk about the software and how configurable this is. Just with files, you can really control how this game works. So now the game is booted. It's passed the self-test. The moderator will basically press a button and a question's asked, and then someone will hit a button and they'll answer, and the moderator will decide is it wrong or right. So if you listen very carefully in the background, when an answer is given, you will hear some audio. So that's part of the game. The audio can be changed. That's totally configurable for each of these actions. So as you proceed through the game, different series of questions. That's all not software. That's easy to configure in a text file. That's easy to deploy. You can change these questions, etc. So it's really a highly flexible piece of software and game platform. So you can customize it for your particular environment.